Howdy mate, this is your Chief Marine Mate Edu. Welcome back to my vlogs. This is a raw vlog actually. So before we start anything else, kindly subscribe and hit the bell button, notification bell should you wish. Now I would like to just to give you an introduction to this video. It's not actually a lecture, it's more on a discussion, an open discussion. This is for us to be able to develop and make this project to be able to meet the students' expectations. So let's go ahead. Right. This project has been undergoing for quite some time, for the last few months, and with the collaboration of experts or people who are involved in programming, scripting, 3D rendering, and to name a few. So we came up with this. So as of now, we are actually utilizing 3Ds and animations and programming, so as to say. Now the purpose or idea of this project is actually intended or addressed for virtual education. So I'm not an educator or educational expert, the samurai master. I may say that I'm not that kind, but of course I have experience also delivery and facilitation and teaching in different institutions and training centers. So as you go on with teaching methodology, from time to time you'll be able to discover a lot of things. You might as well learn from your students, and then as the process go on, you can also discover your mistakes, and you move on with it and try to develop or redevelop and modify the method that you are utilizing, and this way you can improve better. Well, anyway, I'd like to put an analogy. You see, visualization like this one, virtual, is a very nice tool for education. Of course, the theoretical method is still the basis or foundation of teaching, and that is very important. But at the same time, if you could utilize a visualization material and audio, including audio, and that would be, give you a better advantage in inculcating the subject knowledge to the students. To put it in an analogy, it's like if you are a story maker and you want to put this into a paperback writing, like a storybook, and then the other one you put it into a movie, and then you invite a couple of folks. Some will go to see that movie, and the other will be just reading the book that you have written or you wrote. And after that, you just dismiss them. And let's just say that after a year, you recall them, all of these people. And of course, as I have mentioned earlier, there are two groups. One that goes to see the movie you have created, the same story, and the other one who read your paperback writing. And believe it or not, the one who could really relate or tell the whole story or been able to understand the story is, I would say, the one who went to see the movie, because he or she saw it, he read it, if there's a caption or subtitles, and also at the same time he was able to visualize it. So all in one, it goes into one package, and so the experience will be better. In my own opinion, the retention of the knowledge or experience will be longer. So meaning to say, he or she, let's say the student who went to the movie, will be able to cascade that story to another folks who haven't seen it better than the one who read it in a paper book writing. This is just only my opinion and observation anyway, and I think I have experienced it a couple of times. If I want to look at a story and there's a equivalent movie for that, it's a good thing also to read. Actually, it's a nice thing to read. You can as well, of course, exercise your brain to be creative, and your imaginary skills will be improved. At the same time, you can also sharpen your memory. On the other hand, when you look a certain story in a different way, like a movie, it's a lot faster. It's a lot easier. And I'm not saying that you throw away the theoretical aspect of studying. That, like I mentioned earlier, it's the foundation of teaching, and that is actually a very important part of facilitation or teaching methodology. So this is just an augmentation. Now, let's get to the main part. The main part is that I would like you to, if you may have some time to deal with it, if you can actually comment, give us suggestion or feedbacks, or scrutiny, or even violent reaction, if I may say, and that would give us a more what do you call that, opportunity to improve this kind of project. You see, it's like in a game of chess. If you are just watching two players playing against each other, in most cases, you could see the whole entirety of what's going on. While if you try to fit in the shoes of these two players who are fighting against each other, chances are the other will not be able to see the whole entirety, because of course he or she has his own game plan, and so with the other player that he or she is playing against with. So meaning to say, both of them might have a different view to the whole entirety of the game. While at the other end, those people who are watching the surrounding environment has a bigger perspective of what's going on, and that is basically your role, your contribution. We are the players, and that you see, there are things that we don't see when we are developing a certain project like this. While at the other hand, some people who are watching it, or actually, let's say you try to fit in the shoes of a student, and you will see the experience that you are doing when you are using this kind of virtual reality program. Then there will be a so-called a missing link in between, wherein the students or the user will be able to experience directly, and that he or she will be able to see that some might be lacking. And if that feedback or comments or suggestion comes back to us, and then we will be able to develop or remodify, re-edit, and even of course make it more productive, so as to say. So the outcome of the product will be better, and this would mean that we will be able to meet the expectation of the students. So anyway, let's start with no much further ado. It's a lot of blah blah blah. I'm sorry for that. Right, as you can see right now, I am in the bridge. It's called navigating deck. It's basically the topmost part of the vessel superstructure, as they call it, or as we call it. And of course, on top of that is where you'll find the radars and many other equipments like radio antennas, satellite dome, etc. We call it the Monkey Island. I'm not sure how it was called as a Monkey Island. It's probably because people are climbing through that mast like a monkey, maybe. I haven't seen the real definition for that, and I do not know really where it came from. Even I've been 15 years actually in the shipping business, or as a sailor or as a seafarer way back when. Anyway, as you can see, the model is like a general cargo ship. We can also categorize it as a bulker, or those viewers who are in the maritime profession, then they should be able to understand this. Of course, it's also important that we have viewers who are non-maritime related. One is that they might as well give us a different suggestion or feedback, and the experience would be based on their field of expertise, regardless of what is their profession. And with whatever level of thinking that they have, they might give us as well some sort of comments and suggestion. And with that, we can look through it, and we should be able to analyze it if it's applicable to implement it in this project. So, yes, you are all welcome, both non-maritime and maritime people who are following this blog. I would appreciate if you could give us a suggestion. Right. Now, as you can see right now, we included some tools to give the users a way wherein it shows a detailed explanation of what of the ship is all about. Say, for example, this is so-called a PIRB. You can see in that sticker there, an IMO sticker. And if you click on that icon, which is I, letter I, means information. So there you go. You have a description, or maybe a definition or explanation of what that equipment is all about. So in this kind of informative method of displaying a description or explaining, you could actually embed, I'm sorry for that pronunciation, embed a video, a snapshot video, a video clip, or an audio, or even an avatar talking in front of you. So that will give the students a better understanding of what that equipment does, what is function, and so many other, and what are the applications that is for or intended for into this kind of ship. And of course, you can press enter and so on and so forth. So if I go away, it disappear, and as you go and roam around, this is actually a life buoy, smoke life buoy. This is for the so-called man overboard, or MOB. So I don't need to give a discussion about this, but just to give you some overview of what's going on. Right. Of course, for example, that buoy is, we go further and go into this area. That's a life buoy actually. And if you release that life buoy when there is a man who just gone overboard, meaning to say the person was it might have been thrown overboard by a wave or an accident or whatever. Of course, the man overboard alarm will be sounded, or a signal, and then we will release this that mechanism there, the red one, as I'm pointing right now. And this is a 4 kilogram under the SOLAS regulation. It releases, and of course it has a rope attached to the ship, and it should be more than 50 meters, I think, if I'm not mistaken. And of course it also attaches to a smoke buoy, and that smoke buoy will float, and it yields or gives what do you call that, emits a smoke for more than 15 minutes, I think, if I'm not mistaken. Actually, it's all in there in the information. Yeah, 15 minutes, something like that. It's also a LED lights. So basically at night you can see it flashing. So the chances of finding that crew who went overboard will have a higher possibility. So as you can see, you can roam around, you can walk, you can jump. See? I can actually jump from here to that area, that is the top of the hatch or cover of the cargo holds, but in reality I will be dead, because that is like 5-story high from this point, or even higher in big ships. So the whole layout of a ship actually, if we are talking about merchant vessels, we are not talking about naval vessels or naval vessels or military vessels. We are talking about merchant marine vessels, and In most cases, the whole layout is actually a very common design that you'll find on board. Bulk ships, tanker ships, and cargo ship. It's a little bit different when you are in a car carrier, as they call it, or what else? Other ships like what do you call that? Containers. Container ship can also have a similar layout. Just that you don't see this one. You will have a different cargo system in there, but they're almost similar. Right, let's get inside. It opens. As you can see, this is a very interactive virtual tour, and you can roam around the bridge. This is a navigating bridge as we define it, and it is actually composed of different equipments. Basically, it contains all the navigational equipments that is actually found on board navigating, the ship merchant vessels of any type. For example, as of now, I'm looking at through so-called radar. We have here an ECDIS, electronic chart display. Now you will notice that there is a radial or a circular radial spinning. That means to say that if you point your mouse, you could click on it and it shows you a description again. And like I said, I have mentioned earlier, it might show you a video clip, an animation, or an audio information. So it's very informative. Now it's up for the student to see what is applicable to him or her. He can listen or she can listen at the same time. He or she can watch or just read. And theoretically, the students can actually make a reference with the textbook and other educational materials so that they could confirm the information that has been laid out. In most cases, we also did a lot of research. Other than being experienced seafarer, which I have experienced 99% of all these things that you are looking at right now, of course, I can affirm that the definition and description are just exactly as it is at to this present day. But of course, this is for educational purposes. It doesn't mean that you have to follow. And there is always a guidelines and manuals that you can find on board ships to determine the real purpose or
It was at this moment that he knew. He fucked up.
That you can find on board, that you can find the real applications and usage of a certain equipment. Now, although I mentioned earlier that this is not a lecture, it's just something that I can say at the same time while you are looking. I'm touring you around so that you might notice something here that is something wrong or missing. Right, those are the people that I'm working with. I'm not allowed actually to focus that's me there, and there are of course other people there. I'm not actually allowed to show it close as possible. As you can see, you could see also weather map, navigating, and you could see the stern view of the vessel, the aft part of the vessel, the back part. That's the wake of the propeller, as you can see in the water, and it has a CCTV. On board ships nowadays, you will be able to see this kind of technology. So that gives the navigating officer more advantage in navigating the ship in a safe way under the regulations and standard operating procedure of the company that they are working for. There is also a CCTV here wherein you can see the engine control room, and actually that's probably the chief engineer there right now. It's probably my friend Joselito, and there's one there actually, it's another chief engineer, it's Eli, I think, yeah. Right, these consoles as you are looking right now can be interactive. When I say interactive, meaning to say the user can actually interact with it, as if physically. Well, you can even make it in a better method or way of dealing with it. Like if you have the so-called visors that are used in augmented reality and virtual reality, then if they put on these visors, like the one made by Microsoft, which is HoloLens or Oculus, these are quite expensive anyway, but of course for those who can afford it, it is also this program or project can also be adapted into that kind of environment. And when they put these goggles, they can actually like sit into that helmsman chair, and they could, or the captain or the master could actually manipulate those equipment, and it will behave exactly as it should in terms of dynamic of physics simulations in the real environment. What I'm trying to say is that it's like a bridge simulator wherein the vessel will behave exactly with the winds, the current of the waves, and even the momentum and inertia. I'm sorry about that. Right, let's go further. This is the navigating chart, as you can see right now, and of course there are also physical charts, physical maps. Right, and you can see a GPS, many GPS, and you have also the global maritime distress safety system, wherein of course it defines and gives you a lot of information. We have some books there, and then like chronometers. We have this barometer for the non-maritime personnel. They would be able to know some information about a barometer. Barometer represents the pressure, or actually gives a reading about the pressure of the certain area that the vessel is located. And also whenever, even in inlands, at sea level. So this is actually very important to observe the weather of a certain area. So the pressure goes down, that means to say you have a low pressure. So in the Philippines, if there's a low pressure lying somewhere in the Pacific area, Pacific Ocean, then there will be chances that this could develop into a storm or a hurricane, or we call it typhoon here in the Philippines. It's the same type of storm, or they only call it hurricane in the Western world, hurricane or hurricane, however you define it, pronounce it. Right. Now you can also go down and go to the accommodation deck. It means to say you can go all through the alleyways and floors. We call it deck. So now let's go to the captain's deck, and if I open it, I'll get inside, and this is the alleyway. Let's peep through. This is the captain's office. Yeah, you can see there. And this is where the conference room is done. Now the layout might be different in other ships. There is sometimes called a common office, wherein the captain, chief officer, chief engineer, and the first engineer stays or do their work together. And they have their own desk, they have their own computers, and all the necessary documents like books, records, files, etc., and so on and so forth are put in one place. In some cases, or in most cases, they are separated. The captain has his own office, and the same thing with the chief mate and the chief engineer and the first engineer. Of course, the rest of the officers and engineers, they have their own office, small office or table in their cabins. But for the senior officers, they have sort of a bigger room wherein they have a separate office wherein they can work without actually staying in their cabins. Alright, let's go into the captain's cabin. Alright, as you can see, it's almost exactly similar to what you can see on board. It has its own saloon, it has its small office there, and then of course it has its bedroom, and of course bathroom, or we call it head. Right. So the master, of course, the gender is, it could be a he or a she. But nowadays we could find a lot of seawomen who are already master mariners on different kinds of ships. We have, I think there are sea captain who are seawomen who are already master mariners or captains in cruise ships. I think it has been featured a couple of times. And not only in cruise ship but also in this kind of vessels, bark ships and many other types. Alright, let's go out. And so as you can see, you can roam around just as if you are actually on board, and tons and tons of information can be found in this area. So now I am on top of the bridge, we call it as the navigating or the monkey island, where you'll find a lot of gizmos like radar, antennas, I have mentioned that earlier, searchlights, magnetic compasses, antennas, and so on, lanyards. You could see their flags as well. Of course, the flags are a little bit steep. I haven't included the effects of winds and the dynamics of physics like gravity, so it doesn't resemble much of a flag. Right. So we go on the stairs. We are on the boat deck, as you can see. That's the boat deck. Of course, you can see this is a mastering station. So in case of emergency or like abandoned ship, people or the crew members have their own designated lifeboat station, and they will come over here and do the mastering. So once the captain declared an abandoned ship, and then of course everyone has its own responsibility and job to do. Someone has to remove the lashing of the lifeboat, someone has to overhead the winches, or if they can, or everybody could just go on the embarkation deck and boards the lifeboat, and they could just pull the release wire so that the gravity David, this is one type of lifeboat mechanism wherein it releases the boat. This one goes down to the sides, and then of course it can hoist down, lower down to the water. As soon as it gets to the water, you can release the so-called release tension or hooks, and there you go. You can go away from the ship as the vessel, of course, not knock on wood, hope it won't happen to anybody. That's a life raft. It can be manually what do you call that, manually operated, meaning to say there's a hydrostatic, you can see that yellow there, it has a hydrostatic mechanism, so that when a vessel sinks about 1.5 meters below the underwater, and it should be able to cut the lashing materials, and this one should release, and that's the pain there, and it pulls the trigger to the compressed air or CO2, and then of course it inflates the life raft. Of course, I do not need to lecture much about this. I'm only showing things that for you to be able to look at, and that you could give us a comment on what's your thought about this. I'm now actually within the funnel area. That's where most of the pipelines and other exhaust pipe coming from the engine room. This is an emergency generator. Let's get inside. Oh. Now, that's a new thing. I just discovered that I cannot pass through or whatever. Something is blocking me. Let's just go out. We are on the poop deck, or the stern part of the vessel. Yeah, by definition and terminology, poop deck is what we call the backside or stern part. It's like a tail. If you are talking about an animal, that's the tail area. But of course, in shipping terminology, the deck is a floor. We call it floor, and of course, the sides we call it on the right side. We call it the starboard side in most cases. This is a term by the British what do you call that terminology, while the English I mean in the Western system like the United States, they call it right side, and the left side is left, while for most of the merchant marine we call it port side for the left, and starboard side for the right. Forward, that's the forward part, of course by the word itself, forward. And aft, that's the stern, back. And they call it also poop. Poop, as the word implies, poop. That's your back door. That's our back door. Poop. Poop deck. Right, we get into this area. This is another door, safety room. You'll be able to see lots of safety equipment here, like a firefighting fireman's outfit, some fire hoses and fire extinguishers, and self-contained breathing apparatus. I do not know if I need to put in much more in that area. You notice that I didn't show you anything much about the accommodation and the engine room. That's a lot of 3D rendering. It's really huge and it takes a lot of time and effort to do so. Maybe we can do that also in a separate project, but it would take some time, because rendering 3Ds in the engine room, you know, you are talking about thousands and thousands of 3D objects. What is my point? If you, let's just get nearer to this one. This one is a roller guide for the hatch cover. That roller guide alone has a lot of meshes, as we call it, or vertices. So it's basically a very complicated 3D to put up with, and of course it eats up a lot also of space and memory in the graphic processor of the computer, so it slows down the system. Right. Now let's go on top. This is the hatch cover. Hatch is also a cargo hold in bulk ships and general cargo ship. So it has a cover. Now this kind of hatch cover is the folding type. I showed you later. It's a folding type. It is not common in bigger bulk ships because the integrity of leakage is not that great. So most of the time the conventional ships folding type are actually utilized in coastal trade in these days, meaning to say ships that are a little bit smaller and that their trade route is close to the coast or coastal passages. Now the other thing is that for bigger ships you will be able to see also hatches and cargo holds, but the covers are not of this type. Most of them are utilizing or using the so-called sliding type. I'll be showing that kind of model as well in the near future, as long as we have the opportunity and luxury to create one. So that gives us more we can have a better outreach of different kind of models. No, not. I pronounce it I term it the wrong way. We can have more varieties of a variety of ships. Right, as you can see, this is a crane. I don't know what it's made for. Maybe it's a lever type made in Germany. I'm not affiliated with that crane maker, but you'll find that those kind of cranes as very particular in most kind of ships. Now, this is not a gearless type of vessel. When you say gearless, it doesn't have any equipment that is capable of loading and unloading herself. Herself means I'm talking about the vessel. The gender of a vessel is she. I'll talk about that later in some other kind of discussion. Right. So when you say gearless, you don't see this kind of cranes and equipments. They have no cranes, no unloading system. It's just the cover of the hatch and that's it. And some other equipment that is related for cargo operation. But you don't see cranes. Right. In here, we could probably create a door. Actually, there's a door there right now, and I can get in. Let's just go there. Yeah, if I get into that door, there's stairs, and then upon going up or climbing the stairs, I could start the hydraulic motors. And once I start the hydraulic motors, then I'll be sitting inside that cabin control, the black one that you could see in that area, as I'm pointing right now. Though there you'll be able to see the levers of different type wherein it controls different functions of the crane. One is for hoisting, lowering, or heaving up the cables or the runner or the hook. And of course, the one that is other lever is for the jib or the lever arm. You know, it's like moving up your arm like this. And of course, the turret, the whole body, including the arm, you could swing it sideways. So to demonstrate that, you can actually run a let's just say that it's not yet fitted in this simulation, but let's just say that we start a hydraulic motor, and in here, just yeah, okay. So now there should be a sound there right away, and then I could just click this one, and right, wala na. Right, something went wrong. Yeah, it snaps. That is interesting. Sorry about that, folks. Hold on a minute. Right, let's resume. I'm sorry about that. A while ago, the crane system got stuck into that area. One of the missing piece that we didn't put in that area is that in reality there should be a so-called limit switches. It runs about a meter below the boom, wherein that limit switch, when it touches, or this hook assembly touches, including the pulley, touches the limit switch, it will send a command signal to the control cabin of the crane, and it should stop the hoisting or the cable running further or going up further close to the boom, so it won't touch. So because if it doesn't have a limit switch, and the tendency of that is that it will snap. It will of course break the cables, because this is a very strong, let's say this is a 5-tonner type of, capable of carrying 5 tons crane, and you could imagine how strong the cables are, and the motor that's actually pulling the cable. So basically it has a great load, and that if it reaches that limit and it didn't give way, then you will lose the cable, it will snap, and of course it might end up with damaging the crane itself, or in worst cases it could damage the crew or injure the crew operating it. Now when operating a crane, of course in this virtual reality, players can actually interact with each other, meaning to say they could be in one scene, in one environment. Like for example, if the other user is staying somewhere here, virtually the one who is operating that, you should be able to see that one who is standing in that area. And if that is the deck officer or another crew member that is communicating with that control of a crane operator, then they could communicate in two-way, so that they could proceed with the operating procedures or whatever they are doing with the crane operation. So for example, I'm going to show you one demonstration right now. I do it in remote basis for this moment. I'm going to heave up this cargo. It weighs about 20 tons. So as you can see, the cable being pulled up. Now it goes up a bit, right? And as you can see, there's a little bit of dynamics in there, the swinging, because it's affected by gravity. And at the same time, if the vessel is floating, of course the vessel is floating in the water, it is also affected by the dynamic of the movement of the water. Like if there's a strong wind, there's a strong wave, and there's a current, and if you shift the weight or the cargo from one side to the other, it displaces or it moves the center of the gravity in many ways. The center of the gravity of the vessel will of course move dynamically, and at the same time the center of gravity of the crane also moves. So with this, just to give you an example, let's bring it up a little bit, and then we'll swing it on the starboard side or the right side. Now if that is at 20 tons or even bigger, and I'll put it on the right side of the vessel or starboard side, the center of gravity of the crane will go into that area, and of course what happens is that the weight is hanging there. Also the weight center of gravity will move towards that area, that point. Now you have a lot of stresses or tension in that cable, including the arm and of course the whole body or turret. Whether if we call it as a human, that's a torso. Right. So we can actually apply also dynamics of physics into the vessel so that it behaves the same way. If this is a heavy weight, then this vessel should, in layman's term, tilting. Right? Of course, we call it, what do you call that? What do you call that? I'm sorry. Oh, I forgot the term. It's been quite a year. Inclination. It's called heel. It heels. H-E-E-L. Yeah, it heel. Right? But let's just use the word tilting. The Tagalog, in Tagalog, tagilid. Right, it should behave that way. At this moment right now, we are not doing that, but we could apply that. As you can see, the water is calm. We could make that a strong wave with gale winds, and it should affect the vessel accordingly. But if the vessel is alongside a pier, a wharf, a berth, or a terminal, then of course the effects, it depends on the location anyway, but if it's in an area wherein, like the Mississippi, that's a strong current in there, it should be able to affect the vessel. Huge effects on the vessel and the cargo while the crane is moving. Right, as you can see, that crane and cargo is clear from the top of this area. So I can even run. See? Let's start the hydraulic motor again. Right, so I'm just gonna tone down the volume of the motor. Right, as you can see, I should be able to control a different lever or hydraulic levers. Most cases, there are these systems that opens the hats. They are actually with a hydraulic system. Hydraulics basically utilizes hydraulic coils and hydraulic motors. We will discuss those things in other kind of lectures or discussion. You can see it's opening right now. As you can see, let's say, yeah, that's something's not right. A life buoy is floating inside. Right, this is the cargo hold, right? And as you can see, a bulk ship or a general cargo ship can handle a lot of cargo, or you can put in or load and unload a lot of cargo in that area. When I say cargo, mostly they are dry cargoes, especially in bulk. Say, for example, wheat, rice, sugar, iron ore, and many kinds of cargoes. In general cargoes, there are of course a variety of type and sizes. You could load like a truck in that area, a pallet of drums and boxes, and many types of different shape and sizes of cargoes that can be secured in that area. But in bulk ships, typically that is intended for bulk cargoes, mostly they are of the same type. So, for example, if I am loading here wheat, then the whole hold will be loaded with wheat. And that's why I mentioned earlier that we are talking about this type of opening or hatch cover is a folding type. It's not that popular anymore in large or big bulk carrier because of the integrity of the water seal. Because when water gets in, of course, chances of having the cargo being damaged will be great. Of course, they are insured, but there's a lot of money that's being wasted already. And not only that, the water that gets into that area, it may react with the cargo, and it will give trouble, or it will be hazardous and dangerous to the crew. So dangerous in a way that it could literally injure or damage the whole ship, such as explosion and fire, and we don't want that to happen. Right, so as you can see, that's what we are doing right now with this design. And this is not supposed to be the one that opens the cargo hatches. It's supposed to be just a switch to start the motor. But temporarily we have designated this as the one that closes this cargo. So we're gonna bring that crane a little bit further, and we swing it to the right again, or to the left side of the vessel. As you can see, the weight is not that heavy, so as the turret or the arm swings, it's also swinging sideways. Now you could see this actually in real life when you are on board a cargo vessel that has this kind of cranes or cargo operations. So that's why the the crane operator should be well trained, certified to operate a crane. At the same time, he is not the only one doing the job, especially when there are heavy cargos involved. There should be a responsible officer or another crew member that is actually coordinating with the crane operator. In fact, the crane operator is basically just implementing the commands of or following the commands of the officer or the other crew. Because in most cases, in the position where he or she is sitting as a crane operator, he won't or she won't be able to see everything. While of course the one who is on deck, he sees what's going on, and of course he could direct the operation, such as of course they wanted to put this crane to its cradle back to its position. In most cases, the operator cannot see it right away. You can see, did you see that? When I drop the cargo, it hits the hatch cover. Let's do it one more time. Yeah. Ha! Now that is something, because if you manage to observe that, it passes through the steel. In reality, that this is a steel, that is a rigid body. Both of them are solid body, solid objects. So in reality, it should not pass through that area, but it did pass through. So something is not right again with the configuration of the program or the project. But as you can see, the other two boxes went off, so the physics is good actually. Right. So we're gonna heave up a little bit and clear this. Oh no, something is not right. We're gonna heave up this one a little bit so that it gets clear from the bottom. And now we can lower the jib, or the arm. Now as you can see, the crane operator will not be able to see this directly from his position or her position in the control cabin. So he will have the signal coming from the other deckhand. So we're gonna just center it and then bring it up. Of course, in most cases, if this is not in the right location and you go all the way down, there's a limit switch that is also fitted in the system, wherein if you go down right that fast, it should stop, because it has reached already the limit of the crane. Otherwise, if these booms go down further, some structural part of the ship may be damaged or destroyed. Right, so it's almost an hour right now. I do not know if you have the patience of watching all these things that I'm talking about in this video, but I hope you did so that you could comment further and let me know what's your thought about these discussions that I just opened up, and that you could give me an insight or further evaluation. Now you could see also that this is a house pipe and something is missing. There is no guardrail. In reality, you can just go through that hole and then it will be unfortunate that you're gonna go down all the way to the water. Oh no, that's not. Now I got, and because the anchor is inside, I am stuck inside. So the purpose of the guardrail actually is to guard and protect personnel being, that's a big hole actually. It's a house pipe. It's where the chain of the anchor passes through. And let's just jump overboard. Oh, there's a lifebuoy that was thrown immediately. Yeah, there's the anchor there actually. See that one? That's the one that you will lower when anchoring, and that's the one that holds the vessel in place. This is the one that goes down to the bottom of the ocean floor or the sea floor, and once it finds a good holding point, like a mud, maybe a sand will be able to hold it, and now of course you have to avoid the rocks because it won't be able to hold it, and also it might damage the flukes of the anchor. Anyway, I'm just gonna find my lifebuoy. It's gone already. There we go. I'm back again. Something is missing here. I don't have the forward mast light, forward mast, so it's not right. You could actually jump and run, and now I'm jumping here. You could crouch. Oh, I just noticed that there is something floating. Oh, that is strange. So again, as I mentioned earlier, if I have not done this, I might not been able to see this one. This is, I think it's a latch for the watertight doors of ship's watertight door. So it's supposed not to be in that area. It should be in that door, whatever door that is, those green ones. So that's my point in this video. The video is actually intended for you to scrutinize, suggest, and give me feedback. If you have other suggestions that might be useful for us to remodify, or even go back in the drawing table and redo the whole thing until we are all of us are all satisfied, and then of course that's not the end part of that thing of this project yet. Once the project or this program gets into the hand of these students, you can expect, of course, another feedbacks from them. Some of them might be satisfied enough with what they see and what they have experienced, and while some will be looking for deeper expectations, and that is something that you could not always get. It's hard to please people, but the whole aspect here is that we are trying to put up a project that would be able to deliver and meet the objectives of a certain subject or topic or knowledge for a certain level of training in any institutions, or even colleges or maritime universities, and even the instructors or teachers themselves. They could utilize this. I'm not saying that this is good, or I'm not saying that we are patronizing our product, but at the same time, what I'm trying to say is that there are different makers and different manufacturers of this kind of things, and they are even actually prepared and experience in this kind of matter. I'm just a typical programmer who has just been new to the industry. Being a seafarer for quite some time gives me this kind of motivation that what if I will be able to convert the experience and knowledge that I have acquired on board ships into a digital way. Of course, this has been done with other companies already around the world, but I was only thinking that if the developer and the programmer himself or herself is capable of cascading his or her own experience into a different field like this one in programming, with the help of other technical people who are really in line with this field, like computer science graduate, IT people, and those who are really doing the kind of this profession. So if they could work together in as a group, then I think the product will be more productive and would be more better. That is my perspective anyway. I stand to be corrected. It's just something that I am opinionated about. Right, 1 hour and 1 minute of discussion. I hope that I managed to get your attention, and that somehow if you could just give me put down the comments or anything that you would want to put into this open discussion. A violent reaction would be fine. I don't care as long as it's constructive criticism or professional criticism. It's okay. You see, like I mentioned earlier, I am not into this level of expertise wherein I know what to do. I need help, I need assistance, and of course I am willing to learn further so that I could develop my skills and also be able to help also my colleagues who are working with me at the same time, and the implementation of the project plan will be met accordingly. Right, thank you very much for all the viewers, and yeah, I'll be giving a new lecture in the next opportunity. So, a pleasant day to everyone.